I'm going to introduce myself. My name is Kelsey Emnet. I'm the Director of Decision Sciences at Merits. So we work in the rewards and incentives space for the most part. We have an automotive division that I work in sometimes, as well as a motivation division, which is where I spend the most of my time. So we work with airline clients, hotel clients. We work with pharmaceutical, a variety of different clients across different industries, which makes it really interesting to work in different areas and switch it from one field to another in the same job. So more about my background in general. So I have 6 years of experience in data science. I have worked at Bayer, Whole Foods, and Avanade. I was more of an individual contributor before I came to my job at Merits. I'm the director there, so manage a team of now 8. We just hired one more person. And I work in cross-company strategic initiatives, but still am pretty hands-on in the coding, particularly helping my team with it and enabling them to do the work. So that's a little bit about me. And then I can get started with the material. Does anybody have any questions about my background or anything like that? All right. So as for my focus areas, really focus on data science and machine learning above and beyond anything else. So that's where I spend the vast majority of my time. I also have a lot of experience in cloud analytics, so particularly Azure and Google Cloud Platform, but also some AWS experience mixed in there as well. So I would say I'm a little bit of a unicorn where I touch some of the ML engineering as well as the data science. So feel free to ask any questions about like more of the full stack tech stack as well, and what to learn versus one skills versus the other. All right. So I really want to just start with what does working as a data scientist look like day to day? I've worked in several different fields. So I like to tell you a little bit more about that so you get a good idea. So as most of you probably know, data science is really focused on predictive analytics. So predicting things before they occur. It's also focused on, I do a lot of unsupervised learning as well. So trying to understand patterns in data with machine learning algorithms. But it's also really, and I think this is sometimes missed, about storytelling. So we always come with a business problem. You should always the analytics should meet the business problem versus the other way around. So if we come with a business problem, we find a way to solve that business problem with analytics. And a lot of that has to do with in a lot of cases, your day-to-day activities, you have to be very proficient in coding. So that's one part of a data scientist. Generally, I highly recommend Python as a first language. If you haven't learned any languages before, I've used a wide variety of them, but Python is definitely at the top of my list, coming from a previous R coder. So there is always going to be a programming component. So the other component is machine learning algorithms, predictive analytics, and so on and so forth. And often a really interesting part of the job is when you actually work with analysts as well to meet the data science with the dashboarding, which has been something that I've seen really recently in my job. So it's very essential to know about the theory of the machine learning algorithms, how they work, what the guts look like. And I'll go over a little bit more about how I became a self-taught data scientist in a little bit. Because I know a lot of you out there are aspiring data scientists, haven't gotten there yet, but are really interested in it. As far as day-to-day activities, coding is a big one, building the models, but also a lot of data munging. You have to be very comfortable exploring data, finding problems in the data, mitigating those problems using code. Data science is a big problem-solving activity. It really is. You're solving problems every day. It's very logical, so you're solving logic problems, which is one of the reasons I love it so much. It's like a puzzle that you go into every day that you have to solve, and the puzzle usually looks pretty different day to day, depending on what the challenge that you're given in that day is. And there are a couple things that I would say about the field that if you like or don't like these things, it could make or break whether you want to go into this field. Data science isn't for everybody. You have to be extremely curious. So you have to want to look at data and understand the data, look for patterns in that data, and that should make you excited to be able to look and dig into data and understand and uncover patterns. I think of myself as a detective of sorts. So if that makes you excited, that's probably your first indicator that this might be the right field for you. And please mute if coming on. Thank you. I'll mute you. So you have to be comfortable looking, exploring, and continuously learning from that data. The other part that isn't as shiny and nice, especially when you're learning, you have to be comfortable in frustration. That's something that it's usually where data scientists or aspiring data scientists leave this field is when they have a coding problem that they can't solve on day in and day out. And they are not, it's never a comfortable situation for anybody, but being able to get through that. There have been days where I'm trying to solve one bug for 8 hours straight. That has happened multiple times in my career, if not more than 8 hours. So being able to dig in, and even if you're frustrated, going and finding that answer. You have to be very self-motivated to find the answers yourself. You're not always going to have somebody there to tell you and answer every single question that you have. So being able to go, I Google all the time. I've been a programmer for 6 years. There's not a day that I don't Google something. So no one ever knows the answers. No one ever has everything. No one ever has everything memorized. So being comfortable finding those answers. So those are a couple of things. The other one I would say is if you want a job where you learn it and then you leave it and you go to work every day and you leave, that's probably you're not a data scientist. You have to be comfortable learning new skills continuously and continuously adding on and with the new technology or the new models that come out because it changes every day. So if you look on my LinkedIn, I'm certified. I have, I believe, 5 certifications, and that's just from continuous learning and growth. So that's another thing that's really important. So before I go on to anything else, I'd love to open it up for a couple of questions. Please limit it not to how do you become a self-taught data scientist, because that's like one of the next things that I'm talking about. But anything else about the day-to-day, anything you're curious about, feel free to unmute or post anything in the chat. I'd love to make this more of a conversation.
Kelsey, you said at the beginning of the slide that it's about storytelling, but you didn't really go into storytelling. Is that coming up, or?
I can elaborate on that. That's why I would love you to, if there are parts you want to hear more about, do exactly what you just did. So storytelling, I can definitely go into that a little bit more. These slides are bare bones for a reason. So storytelling, I think, really starts at the beginning of a data science project. I actually talked somewhat about this. I spoke for Google yesterday at a conference. So one of the mistakes that I've made and seen people make in my career is not starting with the business problem first. So the way that I love to solve that is actually through design thinking. There are products, my 2 favorite are Miro, M-I-R-O, or Mural. They both do a similar thing. They're digital whiteboarding. So getting with a client or a stakeholder, internal, external, it doesn't matter, but trying to understand the problems that they're trying to solve or mapping out processes if they're building a solution, brainstorming on what they want to solve and prioritizing from there. I think it really starts with that because if you can't understand the business problem, you can't tell a story about what they're trying to solve. So the next part in that process, I think, is really once you finish your model, making sure that you explain it in terms that your audience can understand. So knowing your audience, I think that's step 2. So for instance, at Bayer, it was a very different audience than at Merits. So at Bayer, the farmers knew what linear mixed effects models were. They knew what BLUPs were. My first presentation, they said, "Oh, what did the BLUPs say?" And I'm like, "You know what that is? Oh my gosh! Like, what is this?" That's not very typical, but going in and knowing that that's the kind of thing that your audience wants to know is really important. So that's a big part in storytelling as well. Whereas at Merits and most of the other places I've worked, it's more going to the visuals. I like to emphasize showing, not telling. I can tell you all this stuff about my model and how it works and its accuracy, all of that. That doesn't mean anything to anybody until they see it. So I generally focus a lot on visualizations. So I'm speaking at the Databricks AI Summit in June, and my slides have very few words on them. They're almost all visuals, pictures. So that's another piece of it as well. And this goes with resume writing as well as making a presentation. It's actually the thing I see most commonly that people don't do well on resumes, particularly data scientists, is so what? What is the so what? Why do I care that you found this? What can I get from that? What is the business problem that it's trying to solve? So I can give an example. So I created a consumer lifetime value model for one of my clients, and they wanted to understand in this rewards and incentives program how their program drove value. And one of the things that they wanted to understand is when they made a consumer a better consumer, how much money was that bringing into the company? How much lifetime value did that increase because they changed the behavior of that consumer and made them spend more money or made them a longer, more active consumer? So the business question they wanted to answer in that case was, how is my program bringing value and revenue to the company that I can justify to my leadership, that my program is bringing value? So always keeping that in mind and then focusing on visuals, 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 very few words.
Do you ever get business questions from your managers or whoever that you feel like are not solvable through machine learning?
Sounds like her teams might have died.
Or sorry about that, everybody. Teams has been acting up like crazy at work, and I apologize. So I'm back. So I think the last thing that I was saying is with storytelling, focusing on visuals, very, very few words, and staying away from that as much as possible. There any other questions are about that topic before getting into like training and getting into data science?
I had a question. I was wondering if you get like questions about like business questions that are you think are unsolvable through machine learning, or how do you deal with that? Or are there no bad questions? Everything you can give it a shot at least.
So I would rephrase that a little bit. So I think that there are unsolvable questions. Yes, I found a couple in my career. I don't think there are any bad questions. It's more, is this predictable or is this not? So I think looking into anything is never a bad idea. Being able to explore and see if something works. Failure is actually, I would say, a good thing in this field because it means that you're taking risks. It means that you're trying to innovate. And failing is not really a problem because then you're going to be able to find some areas that were you really hit it out of the park if you're taking those risks. But sometimes you find that when you have a data set, you'll put it into a prediction model and it just doesn't do well. Now, nothing that you do to the model makes that problem predictable. I've seen it in my career mostly when the data was extremely noisy and not collected properly. That is the most common time that I've seen that, where the collection was not done in an orderly way. Therefore, it was not predictable because it didn't have accurate data going in. So junk in, junk out. That's where I've seen it most often. But I would say the other side of the coin is you can do a lot with a little. So I've seen sometimes I've seen uh, data scientists come in, they'll have a PhD or really be coming from academics. And with that mindset, like doing everything the perfect way isn't always possible. You can usually, even if you can't predict something accurately, you can probably find nuggets in the data that are really helpful and bring value to your client or stakeholder. The key here, though, is transparency. So, say you wanted to look at an example is we wanted to look at a promotion impact. With that particular data set, we couldn't look at promotion impact, but we could look at a time series data set and see the increase in the metric they were looking at during promotions. And I just told the stakeholders, this is not a causal effect. This is not an impact analysis. We're seeing that this promotion was associated with an increase, but we don't know. It could have been something else. This is just an exploratory exercise. So really, it's being upfront and honest with your stakeholders. They're smart people. They understand that you can't always do everything that they want on the first go. So just being honest about what you're measuring, what you're not measuring, and trying to bring value with what you have. Any other
I have a
questions?
question.
Mm-hmm.
So I was wondering if you could speak a little bit about the pace, because I am someone coming from an academic research environment, and I was wondering if you could speak a little bit about the pace with which you need to solve business problems. Are you basically, um, you know, in the frying pan about to hop into the fire because you just really need to get everything done? You have 1 week or whatever. Or, do you actually have time to dive deeply into some of these issues?
I think it depends on the field that you're working in. So I think that there are places that are more focused on exploring and solving a problem very deeply. I think when you get to see the really quick paced, it's client facing consulting type work. So if you're in the client facing consulting type work, it's or like have or giving products or building products for clients, you're going to have to move fast. Sometimes you have to, I wouldn't even put it as cutting corners. It's just moving quickly to bring value quickly. And then it all comes back to that same transparency component, saying what your solution can and can't do. I have a colleague that I used to work with at Avanade who works at a very different type of company. He works at a company that's actually creating a deep learning medical technology where they do amazing things like find fall risk from a video in a hospital room. Now he digs into the research all day. He's in the weeds, like really moving. They move quickly, but they move more deeply, I would say. And it's really depends where you are and what field you're in. And you can tell a lot from an interview. If you ask the right questions in an interview, or even just be honest, like I'm the kind of person, I'm a researcher. I really like to dig deep into problems and ask that question. Is this someplace where I'm going to have to move really quickly to get product out? Or is this something where I can do more exploration? If somebody asked that in an interview, I'd tell them, I'd be upfront and honest with them. And for me, I like to work quickly. If I work too slowly, I get bored. So I like to, and I also like switching from one thing to another just because it's how my brain works. It's how I function as a human. So I think companies work that way too. Some people like to do it one way versus the other, and it depends on the goal and the field. I think in healthcare, you're going to find more that it's slower, more on that side of things. But yeah, like consulting, I would say is extremely fast paced.
Great. Thank you very much.
Mm-hmm. Any other questions before we move on? I love having the conversation, so please feel free. All right. So if you think of anything else, please feel free to interrupt me for sure. So other than what is it like? I always get very similar questions. I like to, as much as I can, do mentoring calls and things with people. I've been doing it less often than I'd like lately, but there's a pretty good pattern and it's usually the questions that I had when I was moving into data science. So I didn't get as much into my background, but I started as a statistical data analyst doing public health research. I have my master's in public health from Washington University in St. Louis. So I had statistics background, but it was nowhere near data science. It was just not the same thing. So I had the base in that I knew what a linear and logistic regression was and how that worked, but pretty much none of the rest of it. I didn't come out with any coding experience other than SAS, which is almost useless in this field. So learned a lot of it on the job, and I learned a lot by studying on my own time as well. So one of the questions that I get is like, there's so much to learn. There's so many things that I could dig into. What do I do first? What's most important? So I want to definitely cover that because I feel like I was most overwhelmed, not even by the learning, but it was what to focus on was so hard when I was learning. So hopefully this helps a little bit. So this probably goes without saying, but machine learning and modeling should be your first priority above anything else. Understanding that machine learning and the theory behind the models is really important. I am on the fence in most cases negative towards the auto machine learning side of things because there are so many problems that auto machine learning, at least today, can't solve, where you need a person. And the only way a person helps is if they understand the models that they're trying to use. So I put here a couple of different models and kind of in a little bit of a priority. So you have to understand linear and logistic regression first before moving on to anything. That's 100% necessary. Usually from there, I also, the next one I recommend doing is K nearest neighbors. And then after that, covering tree-based models, first decision trees, gradient boosted trees, random forest. I like to go in that order just because linear and logistic regression is the basis of a lot of things. It's often your baseline model that you use. K nearest neighbors, you don't use much in practice, but it's easy to understand. So it's going to be less overwhelming to learn to start. And then with these first two steps, understanding evaluation metrics, how you evaluate a model, and how you pre-process your data. So that should be, like, from a modeling perspective, definitely your first priority is getting those. One of the bigger mistakes that I see is people jumping to deep learning first. It's like, no, you should be walking before you're running a marathon. You should focus on the things that are fundamental, easier to learn, and then move on to the harder stuff later. So I put like a secondary focus after you have a really good understanding of pre-processing these models listed here, hyperparameter tuning, and model evaluation. You could move on to unsupervised learning. So in that case, anomaly detection or segmentation or clustering is a big one. Deep learning and time series. But I would cover these first. Number two, and it kind of goes hand in hand with number one, is Python coding. I don't recommend. I moved my team from R to Python for a reason, and I actually started off as an R coder. And I can go into more of that if anybody's interested. But what I did actually when I was learning is I read about machine learning models during the week, and then on the weekend I coded it out in Python. So, and from there, I found like a data set that I really liked and was interested in, and basically coded out that model with every new thing that I learned. That's actually what I'm presenting at the Databricks conference, is what I learned machine learning on. From there, I would say number three is SQL. That's highly desired in this field for sure. So that is extremely important. And this one is often forgotten, but I think is extremely important, is communication skills. So I do this class, you may not imagine, but I used to be terrified of public speaking, terrified. Like this would make me possibly just like lose it earlier in my career, because I did not like public speaking. I didn't like it in grad school. So what I did is I started teaching because it made me uncomfortable, because I knew it was important. And the only way that I was going to learn that skill was by doing it. And Bayer had a program where you could learn new skills and new technical skills, and people within the company would teach to others within the company. So I was lucky enough to have a boss that supported me in doing that. But I weight most often when I'm hiring technical skills equally with communication skills. If someone cannot talk to me and explain what they're trying to show with analytics, they don't get hired. So that's extremely, extremely important. It maybe others prioritize, but this will only help you. So only after you have mastered these top four would you move on to PySpark, cloud solutioning, things like that. If you're going towards the data analytics track, I would definitely put dashboarding up in these essential skills. If you're going towards data science, like my data scientists don't build dashboards on my team. So there really is kind of a split of skills there. So hopefully that's helpful. One other thing to show, I know all of you that come to my class pretty often. I'm sure you've gotten this a whole bunch of times, so apologize. But I teach a machine learning class and gotten through most of it. I teach once, basically the first Thursday of every month. You're going to see on here that I have a very specific order and in the way that I teach things. And you're going to see here, like you can actually come into my website, kelseyamnet.com. And I actually have, if you click on a class, I also have reading below that suggested reading that would go with each class. Part of the reason I added the reading was actually for my own team because they're using this as a resource as well. And it also has code, data, and the different slides throughout. It often takes me a little bit to post my classes, but I have gotten most of them up. So I would, regardless of how you learn, the ordering, you can maybe skip over the Python environments if you're focusing on machine learning, but the ordering of this was by design and very deliberate. I learned teaching myself the best order to do it. So this is here as a resource 100%. And I'll go over more about my process in a minute. But going through the skills, do you all have any questions about the skills?
Hey, Kelsey, this is Hunter.
Mhm.
I just want to point out you're doing a fantastic job on this so far, and I'll be honest with you, my career path is not in data science. I'm with a staffing agency, so this is really just more for me learning,
Mhm.
and we deal in the data space. I just want to point out that the communication skills is really important for any role that we're filling with our managers. I
Yes.
think that just goes a really long way, a lot longer than most people realize. If you cannot communicate what you're really good at, it's tough to get the job.
Yep. 100% agree with that. Like I said, I weight it equally with the technical skills. 100%.
I had a question. How
Mhm.
important would you put like understanding the mathematics and the theory behind it, or is that literally what you're talking about when you're like focus on these things, or are you saying learn how to use them and do Kaggles with these these models, I guess? So like how important is knowing the math underlying it?
So I think it's pretty important. So you may not have to understand every single minute detail, but I picked up calculus books and I picked up linear algebra books. It becomes more important once you get to deep learning. Even so, you cannot do deep learning well without knowing the math behind it. But you have to understand a good bit of it. So going through, and I find I'm going to go over my next slide what my process in stair stepping myself into that was, because I didn't have a math major in college. I was a political science and psychology double major, so it was new to me too. But you have to understand what happens and what changes when you change certain things in your model. I'm just gonna bring up something real quick. So I'm going to give just a little bit of a example. So this is a gradient boosted trees is something that I really often use. So if you're using this model and you have look at all of these hyperparameters that you can tune and change in your model. If you don't know what these mean and what they do, you are going to be in an island out on your own and you're not going to do it right. So you need to know when you change the learning rate, what does changing the learning rate do? How does that help you? And in what situations would you want to change the learning rate? And you have to understand how each one of these works in order to do that effectively. So I need to know that, for example, when I change the max depth of a gradient boosted trees model, I would want to, if I'm underfitting my model, I wouldn't want to increase my max depth. If I'm overfitting, I want to decrease it, and why. So that gets a little bit more into the technical, but you have to, in order to understand and model and tune your model effectively, you do have to understand that part of it. So that's why I'm not a huge AutoML fan. I think it's fine for seeing if something is predictable and maybe narrowing down the method. But with the current technology, you still need a human, and you need a human who understands what they're doing. And that's why data scientists get paid well. It really comes down to that. Any other questions about the skills?
Do you think there's anything else that complements the field well? Like if you say you're solving business problems, would like an MBA type of thing complement it well, or would like a project management PMP kind of complement the job well?
Yes, I think it definitely could. I don't think you need those, but I think it could definitely help. What I would say, actually, from my experience, I've learned more from the people that I've worked with than I probably ever could have learned from an MBA. For example, at Avanade, I had an amazing boss who was the best presentation maker I have ever seen in my life. She was so good at it. So she actually created little presentation clones of herself. Like you could see when somebody came in, they would create a presentation, wouldn't be that compelling, but by the time they had been there 6 months, the whole team, all of their presentations then looked like hers. I learned how to make a presentation, and now I bug my team like crazy because I'm super picky, like she was, like she did for me. Another thing that I would say, so a person that I work with now, she's so good at understanding the business problem, connecting the analytics to the business. I had been doing this for 5 years. I learned more from her than I've learned from many people in my career. So watching them, asking questions, learning from the people around you, I think is going to go even farther than an MBA, to be honest. Making sure that you're leveraging your teammates, collaborating, and going to companies where that's valued, I think is important too. Otherwise, you don't learn a whole lot. But I really recommend leveraging your teammates on that aspect. And I try to do that with my direct reports now too. So. Any other questions? I'm curious what you think about master's degrees based on what you've seen in hiring. Somebody just asked that question. So I would say I think a master's degree matters if you don't have any other experience. So if I had somebody, like I hired once a data scientist who had a master's degree in data science. She didn't have much experience in the business or just experience in general. So hiring her, that master's degree helped build her resume, and that was one of the reasons why I hired her. But I've also hired a teacher where she had a bachelor's degree and she taught high school math for 11 years. She didn't have a master's degree, but she could communicate really well. She took a data science boot camp. She seemed to understand, have a really good grasp. She was a great hire. She's awesome. So I do think I probably have a different perspective than a lot of hiring managers, though. I would say, like, I think that's the way it should be. You take a candidate holistically and looking at that. But I do know companies that won't even hire somebody above at a senior level if they don't have a PhD. So that does really vary. Now, I think it will go more and more and more and more towards the side that I just described, as there are more data scientists needed, and as the field grows. I had a really good boss once say, "You're never going to find somebody who knows everything. And what you need to do is hire somebody who wants to learn, excited to learn, can learn quickly." And she hired me when I knew nothing. So, and then she gave me opportunities and I learned from there. So I try to evaluate candidates holistically. And if they don't have a lot of experience, a master's degree helps. But if they have life experience, like a math teacher, I mean, that's enough for me. So this is a very common question I see in the chat. I just started my career as data science with no strong background and want to become a data scientist eventually. Love to hear your advice on how to be a good data analyst and how to slowly make the transition to becoming a data scientist, skills wise or in general. Thank you. That is a very common question. So as you heard, I was a statistical data analyst and moved into data science. So I think the first part of it is in an interview expressing your interest, and with your boss expressing your interest. So I have a team. I hired 2 people as data scientists. I have a bunch of data analysts who want to become data scientists who I put on data science projects when something comes up that I think would fit their skill set. So Bayer was a bridge role. It was called a data scientist, but I was really half data scientist, data analyst. So finding that bridge role where you may be doing mostly dashboarding and analytics and statistical analysis, probably for 75% of your job, but finding that role where somebody is going to help you or be willing to give you opportunities to learn, I think is going to go a long way to get there. So the part about that, and this is what I've said to my data analysts on my team, is you have to do the work. You're not going to just become a data scientist overnight. Even doing projects at work, you're still going to have to read or watch videos, whichever one you like, on your own free time, and learn more about the different skills. So that actually lends into a little bit more about my learning path. I definitely want to get into this before the hour ends. I did leave and put it to 8:30 Central, because I figured there would be a lot of questions. But I think that this will help answer your question, and it was definitely planned and common thing that I got. So this is how I did it. First, find the best way that you personally learn. For me, it's books. Videos don't do it for me. Like, I cannot, it's just not the way I learn. So for me, I like to read in order to learn machine learning. I know people who are the exact opposite. One of my data scientists just had a conversation with her, and she said, I don't really like the books. I watch your videos all the time. I like to learn through that. So Andrew Nigg is a really good one on Coursera if you're more of a video person. So that one would be one that I'd highly recommend. I'm not a big video person, but I've heard a lot of good things about him. But for me, I followed a very specific process. So first, I would read about a model and a selection of books, which I'm going to show in my next slide what I recommend or how I did it. There are other ways to do it too. But I would read about a model. I'd often read the chapters more than once. And then I usually used 2 books. And one was a much easier book that really didn't have a lot of mathematical detail in it. It was not enough to actually put you through on the job, but I dipped my toe into it. So when I got to the harder books, I understood more of the concepts so I could get more easily into the math without getting bogged down in everything else. So that's the first thing. I would read about a model, and I recommend that ordering. Even if the book goes in a specific order, I would probably jump around to the order on my website. And if there are always going to be things that, even if you read 2 chapters on something, there are going to be specific parts of a model that you don't understand or you feel like they didn't cover well enough. From there, I always supplemented my knowledge with specific topics from web sources. So I'm going to go back to my website for a second. Every time I would learn about a model on the job, I started just kind of putting links into a Word document and made this. So it's not exhaustive, but there's a lot in here. I have here broken out by the different areas, some of the articles that I found really useful. So you can see data preprocessing, splitting data for training and validation, imputing missing values, random forest, and it goes on and on and on, but it's broken out by the different types of models that you might see. So a lot of this was done. For example, the first time I read about decision trees, I did not understand what impurity meant and impurity decrease. And judging splits and how they would find whether a tree split was working or not. I just didn't get it in the first 2 books. So I went and I read more on a website to supplement that knowledge so I would get a full picture. And once I read a couple websites about that, I'm like, oh, okay, now I get it. So I really use the web as kind of a supplemental piece on top of that. And then, so like I said, during the week, I would do that. On the weekend, I would code it out. So I choose a data set that you're interested in. And for me, I wanted something like, I didn't want a Kaggle data set because I wanted to have something that could maybe potentially bring value to somebody someday. And I started off in healthcare and moved away from healthcare. So it was something I was interested in. So in my case, I used the treatment episode data set. To learn to code, I had to take that data set from nothing and do the feature engineering myself and go through. The treatment episode data set is what I use for my classes, and it's every substance abuse treatment admission that is publicly funded in the United States. So I used that and predicted repeat admissions in this case. And every time I learned a new model, I added it and put it on and did it with that data set. And I have been building models on that data set for 4 years. And now I am presenting it at the Databricks AI Summit, one of the biggest conferences that in this field. And I'm actually going to try to sell it as a service. So you don't have to go that far, but just finding something you're interested in, you're passionate about, and then coding that out. Just for your info, I did put on here my GitHub that goes through for my different classes, the different code that I did on this. And that code got better and better and better the more I learned on the job. I started off with something like more one-off, and towards the end of these classes, I've been teaching with pipelines and things like that because I learned about model pipelining. So really recommend doing that and finding a real data set that's dirty. If you don't have a dirty data set, you're not going to learn what it's like to do it in real life. So find something that you could legitimately, like Kaggle data sets aren't dirty. They're just not, they're already pre-curated, they're already pre-merged in most of the cases, prepared for you. Get something that's messy and actually build it from scratch, and you'll also learn to code a lot better that way too. As far as the books go, this is what I did. So I started with machine learning with R. I do not recommend focusing on the code in this book. It's not particularly good. Focus on the concepts, kind of put the code aside. For R code, it's not good. But it's really great for a very bare bones introduction to what you're learning. It's really base level, so you can get a good idea of what's going on from a conceptual level before moving to something more difficult. I tried to start off with this book and I was like, I understand nothing about what they're saying. I don't get it. So then this was like my second try, and I'm like, oh, and after reading this one, I was able to understand this one. I just needed a better foundation. So you're not going to know data science after reading this machine learning with R book at all. You're not even going to be close, but it will make it easier to do books like this that are more math heavy and learning through that. And then you'll learn a lot with Googling stuff when you're coding too. So that's really important. So that gives you an idea of what I did. This may not be the best way for you. Like I said, you might be a video person, or maybe that this method doesn't work, but maybe understanding the framework, I would say you have to code it out though. You can't get away from doing that. You cannot learn machine learning from a book. You have to code it because you're going to run into problems and you're going to have to figure out how to solve those problems. And until you do that, you're not a data scientist. So I'm going to stop. I'm sure you guys have questions about that.
I had just kind of a general question, like, how much flexibility in your schedule do you have? How many hours do you work? Like, what's the work-life balance? I'm coming from academia, so I'm a little bit spoiled with some of that, I think.
Mm-hmm. So again, it definitely varies by the field. I would say in data science, it's heavier on the hours. So that's something just in general I found challenging. However, I've worked at companies where it's clock in and clock out. So you can get a good feel of that sometimes in the interview process. It's really hard to get a good feel about that. So I would say from what I've heard, retail tends to be on the slower side. Like there's less hours, more work-life balance. Like working at Whole Foods, there was a lot of work-life balance there. Um, Working in consulting, if you want low hours, consulting is not a good idea. It's a bad idea. So client-facing work where you're selling a product, just in general, it tends to be heavier on the hours. Try to be honest and fish that out as much as you can in an interview. But also when you're starting to learn and you're just starting in data science, you're going to have to work long hours just to learn what you're doing. So you're never going to be able to clock in and clock out as in your first data science job if you want to learn to be a good data scientist. Like I did my job. I might have done like 10 hours at Bayer in a day, but I went home and studied because I still didn't know what I was doing. I had no idea what I was doing. So there's a lot of development aspect, especially if you're not coming with a data science degree. It might be a little easier if you do that, but I would say it's probably one of the more heavy fields and hours, just if I'm being honest with you. And a lot on expectations is going to depend on who your boss is. So I make sure the people on my team have work-life balance because I know it's important and I care about them and their well-being. I won't let them be too far overworked because I don't think it's right. So I enforce that on my team, but I know that they go home and study outside of the job too. So hopefully that answers your question.
Thank you. That's super helpful.
Mm-hmm.
What's your recommendation for the dirty data set?
Sorry, can you repeat that?
Recommendation for the dirty data set. Any website or anywhere where I can find the dirty data set?
Anything in public health. So I was very, I would say, fortunate that I started off there when it comes to dirty data. So there's a lot of really good publicly available data sets in public health, but they usually come from the government, and the government aren't data people for the most part. So they're usually, you have to like stitch multiple data sets together to make a conglomerate of data sets. Where the TEDS data set, everything was a number and I had to completely recode everything. So that's something that that's where I've gone. That is definitely a dirty data set. There's a UCI machine learning repository that also like it's not like Kaggle. I mean, there's some dirty data sets on this. So like there's one product recommendations that I did and used for like a case study. And it was on the dirty side for definitely from this website. So I would say this is a little bit better. I would say it's still on the cleaner side than you would see in real life, but I recommend getting some census data and finding something that you're interested in that maybe at a county level. Like stitching that together is going to be hard and worthwhile.
Thank you.
Yeah. So I'm reading one of the questions. Yes, so somebody's asking a little bit about Python and R. So I've learned the primary focus models in R, now deep learning in Python. Over the summer, would it be helpful to turn my primary focus from in machine learning to Python? So a little bit about that, there are many people who would disagree with me. But I came into Merits and they were trying to train a 2 million row data machine learning model in R on a desktop. That does not work. You could pull that off in Python. It wouldn't be easy, but you could pull it off. The R caches to memory, whereas Python caches to the location of what you're looking at. So R is very, very memory intensive and you cannot scale it. I don't care what anybody says, it is hard to scale R. And I honestly was frustrated enough that I gave up pretty quickly. When I worked with smaller data sets and in statistics and not doing heavy processing, machine learning was okay for that. I mean, R was okay for that. But in general, Python scales so much better than R does. So that's why I moved my team to it. It's also more flexible. Like I find a lot of package conflicts with R and it's just kind of finicky and frustrating. That happens in Python, but it's a lot less common. And you're also able to work with environments a lot easier and set up environments where those things aren't an issue because it's more like developers used it first. So it's more it goes towards the solution side of things as well. The cloud, you're never going to almost ever see any R code for building cloud solutions either. It's just, and that comes back to the same thing. Python is really flexible a lot across a lot of different areas, but the scalability, that's really my answer. And that's why I moved it took considerable time to move them from R to Python. We did it. It was a long process, but it was worth it because in the end, even the things that we tried to keep in R, we eventually had to move to Python anyway, because once the data grew, the R solutions broke. So it's a long-winded answer, but I really recommend, as an R user, I never touched Python for the first 3 years of my career. From somebody who used to love it, Python is better for data science. That's just my opinion. Like I said, many people would disagree with me, but that opinion comes from experience.
I have a question. What's your thoughts on Julia and Go?
So I found just in general, that's, I would say, more on the software engineering side that I've seen that. I've more seen things in Python or PySpark. When you're building machine learning solutions, those are better from what I know. And I only have limited experience. But so if you're building like actual applications with machine learning, I believe that's more where that comes in, more on the software engineering and application building side of things, because those languages work better with that. I'm not going to speak any more about it though, because my knowledge is admittedly pretty limited there.
Hi, excuse me. Can I ask a question? Do you have any recommendation for students like us to learn something like PySpark and how to learn it systematically, since that we do not have such program or courses to help us to learn these things like PySpark? Thank you.
Well, I actually have one. So,
wow, thank you.
Yeah, so if you come in here, I have a couple of tutorials, basic statistics. I have R programming for when I used to be more focused on R, machine learning, and I have PySpark here. So PySpark is my favorite language by far. I like it better than Python. I like it better than any other language that I know. I love it. It's expensive to build solutions in there, so you don't get to use it all the time, but I really like it. And here, this goes over a good amount of what you would need. And it gets into the machine learning in PySpark in class 4 and class 5. I also if you go into my information and resources, I have a useful books section. This book is amazing.
Well, I know this series, yeah.
Oh my gosh, I've never liked a programming book ever in my life until I read this one. It was fantastic. And if you want to prepare for the Databricks certification exam, it's this book. I mean, it's really this book. This one I liked because it was more updated, and it had some stuff on like Delta Lake and ML Flow and things that were more cutting edge. And this one had a couple of pieces missing, but this was an amazing resource. So highly recommend using this. I did. So yeah.
Thank you so much.
No problem. Any other questions?
Hi. Actually, I have some questions.
Yeah.
So I'm fairly new to tech. I have a very unrelated field, and I'm really trying to kind of move over and come into tech in some capacity. And I was wondering if you would have any idea of where to start, because unfortunately I wasn't able to listen to everything because I'm actually driving. So yeah, because I didn't have time to sit down and unfortunately really like sit down and do everything. But yeah, like that was kind of my question is, and I got a recent job opportunity from my school, and I'm a little confused because they don't want anyone with experience. They want to train people from the ground up. My only thing is I would have to move to New York, and it pays decently. But I'm just kind of like, what do I pick? What do I choose? Where do I go? But yeah, I was wondering if you had any insight on where to start here in Chicago, or that's where I am right now. So
yeah. So, and this comes back to like maybe data scientist isn't the right thing. Maybe you just want to be in some type of tech. So there's a couple of things that you could do. So if you actually want to be a developer, I really recommend starting with Python because you can be like a software developer with Python. You can be a data architect with Python. You can do so many things. You can be a data engineer with Python. You can do it goes across a lot, like a wide variety of different technology areas. So it's a good place to start to see if that's like something that you even want to do or like. So if you're going the developer side, I would just say get your feet wet in there and think and see if you like it. Programming isn't for everybody. If you're not wanting to go the developer side, product management is also something that's going to be really interesting, or and being like a product manager for AI and machine learning, something like that. So what they do is generally like they manage the development of a machine learning and AI product or a series of products. So working with the developers, managing them, keeping things on track, trying to be able to work with stakeholders and sell that across the business. And project management as well is another way to get into that as well. So you're in the tech, but you didn't start off in tech, so developer may not be what you want to do. So I actually have a product management intern. So maybe looking for opportunities where you can get your feet wet there. So I think that there's more than one route. Like you can do a lot with Python in pretty much any technical area. But if you just want to be in tech, that's another option. Being more the facilitator, a lot of coders don't want to deal with that stuff, the product management or the project management. So they often hire people to do that.
okay, thank you. Actually, I wanted to ask just another quick question is, I am taking like Google Python classes. I am on like a little bit of hiatus because I went through a move, but I was wondering if you would say if like there is like a certain place to learn Python that you would feel is best, that would ideally would be free.
So I would say the place that I've first taken, so it's not free but it's pretty cheap. Oh my, Data Camp, I'm a pretty big fan of. It's only going to get you part of the way there. The reason I like it is because it makes you do the coding. It tells you, and it makes you actually write it out, and then it'll help you like say, oh, that's wrong, you need to recode that. Because it's really hard to learn tech by not doing tech. Like it's just, you have to learn by doing. And from there, that's going to be helpful. I know some people do Coursera, but again, I come back to the I learn by doing. But your best option, though, again, I go back to finding a dirty data set and trying to do something with it. Data Camp will get you the foundation so that you aren't starting completely blind and are just completely overwhelmed. It's going to get you some of the way there, but finding that dirty data set, nothing is going to help you learn more than that. Because you're going to run into problems. You're going to have to solve those problems on your own and go through that. That's what's really going to teach it to you.
Thank you so much.
No problem. Any other questions? I love the questions and all the discussion. It's great. Keep them coming.
I have a quick question. As you mentioned before, there are different people have different thoughts, different ways to learn. I'm a person kind of more like to see the videos instead of reading the books. I do want to do the code by myself, but I kind of want to like follow by the videos. So you mentioned there was a course in Coursera that they're the person you recommend. Can you just say their name or type it like on the chat so that I can find him?
Andrew Nig on Coursera. I wouldn't do his deep learning stuff right away, but he is. You can top Andrew Nig courses. You can see here. I'll put this in the chat so that you have that. Yeah, and he does other things like ML ops and interesting other areas, not just like machine learning, but AI for everyone. You can see. I really want to take this one, actually. I'm really interested. I just haven't found the time. But I would just make sure you're going with some of the basic ones first before going into like deep learning and convolutional neural networks, things like that. So that's one. If anybody knows of any others, like I said, I'm not a huge video person, but anybody, feel free to put resources in the chat if you do know video, good videos. I'm sure many people would be able to use them. So,
thank you so much.
So I just got another question, and I actually neglected to say this one, but it's a very common question that most people have, and I like to cover it because it's a good way to waste a whole bunch of money if you don't do it right. So which certifications would be the most beneficial when starting out? So I have a pretty strong opinion on this. So most certifications aren't worth your money. They're going to get you nowhere, the vast majority of them. If you see a data science certification, there is no good data science certification in existence that's going to help you get a job today. It stinks, but that's the way it is. So the ones that are really helpful, and I'm just going to go into my LinkedIn here for a minute. Real quick. So hold on, it's getting, so I'll talk while that's loading. But the number one, like, so first, if you're like in data analytics, I've heard that the Tableau certification is pretty good. So that's something like if you're on the data analyst side, I would definitely say that those types are going to be helpful. But you're going to see a trend in my certifications. First, so I would say this.
Kelsey,
like,
you're not sharing anymore.
I'm not? Okay. Thank you. Very slow. Okay. So you're going to see here a trend. So one tidbit that might be helpful for you. PySpark developers are in very, 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 very like high demand, and there's not enough supply for them. So if you need an in to get a job, you have to learn Python first, or it's not going to be very helpful. But if you learning this skill will go a long way, because there were at least 100 openings at Avanade before I left, just for people who knew PySpark. They couldn't hire people quick enough. So that comes back to this certification is the best one I've ever gotten in my entire career. Databricks Certified Associate Developer for Apache Spark 3.0. I learned more from this certification than I learned from all the other ones combined. So it was really helpful. I also got the Associate ML Practitioner, which was somewhere in the middle, I would say. So the other ones that are going to be really beneficial for your career are any of the major cloud platforms. AWS, Azure, Google Cloud Platform. Any of those certifications are going to be worth your money. They're going to be worth your time. So highly recommend those as well. Outside any data science certifications, so if you see something where taking a class gets you a certification, that's not going to do anything. As a hiring manager, I don't look at that. So anything outside of that, visualization software, I think also I've heard very good things about, like Tableau, but I don't recommend doing certifications outside of those different areas. Otherwise, you're going to waste your money and pay money for something that a hiring manager isn't going to care about. Just my 2 cents. Any other questions? I'm going through.
I think you can take those 2 cents to the bank. That is all absolutely correct. In the market. That is 100% correct.
Yep. I've hired a lot of people recently, so. I don't see any other questions in the chat.
So I'm hearing a lot of things, like from reading from the website and all those stuff. So you have to be good in one area of ML, like supervised learning or unsupervised learning or reinforcement learning. So my main intention of this question is, so what about in the job market? Is knowing one area, expertise in one area will make better, or all-rounder in all the areas is much better? What's your preference and suggestion?
So I think that probably some people would have a different answer to me. Obviously, you're asking that question for a reason. I actually don't agree with that. Obviously, because I kind of went the other direction. So if you look at a job description, even when I'm not looking at a job, I always make it a habit to look at like good companies and their job descriptions. And I look at the lists of skills and make sure if I don't have those skills that I work on getting them. So you're going to notice that all the major machine learning algorithms are going to be on most data science job descriptions. You're going to see that full stack data science is becoming more and more and more common, just in general, being a full stack data scientist. So actually building the solutions for people. So I think, in my opinion, having a broader knowledge is going to be more helpful, because you have to have a certain level of broad knowledge or people aren't going to hire you. After you have like that broad knowledge, I think you could go either way really and be successful. If you're really interested in a certain area, like there are people that do NLP all day long and that's what they like to do, that's what they want to do, then you should go that way once you have your base done. There are people who only do deep learning and that's what they want to do. If that's what you're interested in, I think that that's a valid choice too, but I think you have to have the base of the basic things that are on data science job descriptions, or it won't be helpful. On the other side of the spectrum, I really like being more of the full stack data scientist. That's how I got my director job, or a big part of it. teaching was one part, I was told. The other part was, we don't have anybody who can deploy anything, and we know we're going to need somebody. So they wanted somebody who could do both. And as a consultant, I started at Avanade, I was a consultant. You had to. If you were the only data scientist on the project and there was a data engineer and a data scientist, well, you're going to have to build it. So that's more and more common. And I like the cloud. It's interesting. I just like digging in to the architecture and the building solutions. But then it goes back to the first part of my answer. If you're interested in deep learning, go towards that. But I really kind of like learning the whole thing. And I've gotten job opportunities that way too, because I can build solutions from end to end. So I think it's based on your personal preference, but getting that base is essential. So knowing the base or essential algorithms, because deep learning isn't going to work for everything. You're still going to have to know the others.
Thank you. You answered my second question as well. So that's what yeah, that's what I'm saying. Like now, even machine learning is not the machine learning. Now, deep learning is what they're saying as a machine learning nowadays. So that's my main intent of question is. So now I know I'm working and practicing on supervised learning. So all the job profiles, most of the job profile I see is minimum of any one framework of deep learning. Okay, so that's what my intention of question is. Okay, do I need I am in a dilemma. Okay, do I need to be good, get strong in ML, then move on to deep learning, or because of a lot of jobs posted have deep learning minimum, any one deep learning. They also mention ML algorithms, all the such, but still deep learning is there everywhere. So that's why I was in a dilemma. Okay, when I need to move to deep learning to go into this data science career.
Well, I can answer that with my own experience. I don't know deep learning very well. You'll notice on my website that I don't teach deep learning classes, and I don't teach them for a reason. So I kind of got thrown in more to the full stack area, and I knew that was that's the hardest thing to learn if you learn it the right way, deep learning. And I just never got around to it. So when I've been in job interviews, I've actually gotten offers from companies that only did deep learning, believe it or not. And I'm just very upfront and honest about that. They'll say, do you know deep learning? I'm like, well, I've studied it. I've learned about it, but it's not on my resume because I don't know if I'm functional, but I don't think I could answer in-depth questions about it. And most of the time, and it depends who you're applying with. If you're applying to like AWS or NVIDIA, yeah, that's going to be on the job descriptions. But people are willing to take a chance on somebody if you can learn the other stuff. And that offer that I got that I actually didn't take, but for that deep learning company, they're like, well, you can figure it out with scikit-learn, and you can build models that way. You can learn it with TensorFlow. You can learn this. Like it might not be right away, but so I would say the biggest thing though is being honest about your skills, because with the way people are interviewing for these positions nowadays, they're going to catch you if you don't know what you say you know. So I've been in those interviews. I say, I don't know deep learning very well. I'm functional. I could learn it on the job. I'm interested in it. I've done a little bit of it, but it's not my area of expertise. So you'll notice just in general, I tend to try to be more reasonable on this side of things, but job descriptions are kitchen sink. I don't like that, but if you have 50% of what's on a job description, if they're those kitchen sink job descriptions, you have a pretty good chance of getting an interview. So I would take the minimums with a grain of salt, and just try to apply anyway. So.
Thank you. Thank you so much.
Hi, I just have a question. Like in the books, there are always a lot of math. So I just wonder, in the job, do you still need to understand the whole thing regarding the math front?
Yes, I think you need to understand a very large portion of the math. Yeah, like I have a couple of calculus books next to my bed for a reason. It is more or less important based on the algorithm. There's not as much math with k nearest neighbors. There's not as much math with decision trees and gradient boosted trees for random forests. So those are easier to learn because they're not as math heavy. Now, if you go to principal component analysis, you have to get back to machine learning and you have to understand eigenvalues and eigenvectors in order to use it effectively. Now you get to deep learning, and that's a whole nother ball game. It's extremely math intensive, and you have to understand the math, or you won't know how it's working. I am a big believer in there's a reason data scientists exist and we haven't moved to auto machine learning solutions. It's because of understanding the math and how things change based on things that you change in your model. If you don't understand the model, you're not going to be a good data scientist. Just my opinion. I've actually seen people try that because they got into a rush on the job and it generally didn't end very well.
Thank you. Yep.
All right. Any other questions? So I'm going to pose a question to you guys, actually. So I know a lot of you, I've been doing these classes a while, and a lot of you haven't been on the full journey with me. You've come along the way. So I've done most of the things outside of deep learning in my machine learning class. I've taught PySpark. I could do a couple things. I still want to keep going with this. One thing that I could do is start back at the beginning and reteach the classes from the start. So starting with pre-processing, going through it. That's like option one. I could teach Python classes and focus on the actual coding. I haven't taught Python classes before. What would you guys prefer, or is there something that I haven't taught that you'd be interested in learning about? I've done most of the basic supervised machine learning algorithms. I'm doing an anomaly detection one soon. I've done one time series and I'll be doing another time series. I've also done segmentation and a little bit of model pipelining. That one won't get posted because it got interrupted like 20 times within it, and I had no time to edit that much. So unfortunately that one's not going to get posted. But what else would you guys be interested in learning? I would love to hear more about that. EDA and data visualization. I will get someone from my team to teach you data visualization because I don't do pretty data visualizations.
I mean, for me, I think I would say, just because I'm trying to get back into learning Python, the Python classes, that's just me though. Mm-hmm. Yeah, so that's something that I would like someone to help me kind of walk through that.
Awesome. Yeah, any other, so I hear somebody on the cloud. That one just might be fun to kind of get into that a little bit, some of the basics of the cloud. I like the cloud. All right, so it looks like some of the consensus is Python, but I've been doing this a while, so if there's any other comments or anything, like I'm very open to ideas. Awesome. All right, well, so it looks like Python Cloud ML Ops is super interesting. So yep, maybe a variety. How about a variety? Let's start doing more of a variety than a sequential class aspect. So I'll start doing that. Feature engineering, I do have a little bit of a feature engineering class. I have not posted it yet though. I didn't get too deep into it, but that one is the next one I need to post. It was recorded, so yeah. So all right. Well, I really enjoyed talking to all of you. I really appreciate your time, and this was super fun. I'm glad we did this. Hopefully this was helpful for you, but please remember, my website already has quite a few classes on it. I'm just going to put it in. It's really easy to remember because it's my name. You can find all of my classes that I've done before on there, code, slides, the video, the works. So you can find that there, and look out for some Python classes and some cloud classes coming up. Really enjoyed speaking with you, and thanks for the engaging, wonderful questions. Have a good night, everybody.
Thank you so
Thank
much.
you. Thank you. I was going to ask, is this recorded?
Yes, I will be posting it. I may not get around to it right away, but it will be up in the next couple of weeks.
Okay,
Yes.
thank you.
It'll be on my website. Thank you.
Thanks, Kelsey.
You're welcome.